Okay, everyone. So this video is the first in what will be a series that are intended for the people who've expressed an interest in following along with my DIY one-wheel build. I'm going to be attempting this build based on a few other builds that have occurred here on YouTube, plus some things that I've learned on my own over the years of making things. This first video, we're looking at batteries and power source. Now, we're making this in the middle of the Great American Lock-in, also known as the COVID-19 global pandemic, which means me as a freelancer doesn't have a lot of work and consequently doesn't have a lot of income. So we're trying to do this with things I've got laying around the building as much as possible. Now, 3 years ago, I built a ride-on atomic bomb, largely out of hoverboard parts. And because of that project, I am blessed with an inordinate number of hoverboard batteries. Now, these may not be the perfect batteries for building my DIY one wheel, but what they lack in perfection, they make up for in being effectively free, because they're already in the building. Now, today's video we're going to look at these batteries, and I basically want to establish that I can charge them without resorting to what I've been doing for the nuclear bomb. The nuclear bomb, I have just been taking the batteries out and using the hoverboard motherboard to charge the batteries. Effectively plug the battery in there, plug the charger in here, plug the charger into the wall, charge until the light turns green. Not really the greatest system because there's this motherboard in between. From my research, I've essentially established that it should be possible to connect this directly to that. There is a BMS board that's actually under this area here in the battery that will manage the balance charging along with the charger here. But I need to test that by making an adapter to plug these holes into those holes. Fortunately, I got everything I need around the building or on this motherboard here. So with a little cutting and snipping and soldering, we should be able to test this to see if it works. We're over at the Hammerspace soldering station now. And what I'm going to do to try this is essentially just cut this charge input lead off and attach it to a new RC battery connector. The reason I'm going to do that right now is because I don't actually want to cut up the charger. I would prefer to leave the integrity of all this intact. So by cutting on this, I can solder this back onto the board no problem if this test doesn't work out. But that cable, I'd rather not. Let me see if I can find some wire strippers around here. There we go. So as we work, we'll talk a little bit about these batteries. Both of these batteries came out of hoverboards that I believe were RMAs. We have a member here at Hammerspace who for a while worked in 2015, 2016 with a leading distributor and manufacturer of hoverboards, kind of at the height of that craze. And from that, he ended up with several pallets of broken and damaged hoverboards. So over the years, we've used them for all sorts of things, including, building a ride-on atomic bomb. These batteries come from a variety of manufacturers. When I first picked the 6 that go with the atomic bomb, I basically went through and tested them all with a battery meter to see which ones were holding what capacity. These are battery number 1 and number 2 from the bomb. They're actually the only 2 I have left. The others have gone to various other projects. But we can get more if we need to. Nameplate capacity on these batteries, meaning what they're listed as on the front of the battery, is 36 volts nominal and 4.4 amp hours, or 4,400 milliamps. Whether or not they hold that is highly debatable. Both of these batteries, according to their manufacture date, are 5 years old now. But like I said, we're trying not to spend a lot of money on this project. And if it works well, and if the batteries end up being the weak point, then maybe I'll come back and spend a little bit more money upgrading things. And the battery is a really easy drop-in upgrade if that ends up working out. So what I'm doing now is I've just The hoverboard uses doubled leads here to make sure it's carrying enough amperage capacity to the battery. What I've done is I've twisted those leads together and put some bits of heat shrink on there. And now I've set up the new battery clip, which is kind of stiff. To keep it from deforming while we solder, I like to plug just an unsoldered clip into there. And that just makes sure everything stays where it needs to be as we work. Now conveniently these are labeled. This side with the shape to it is negative, so we know the black wires need to go there. Tin that with a little solder and put the lead in. Now these batteries, back in the 2015, 2016 era, around that time, they did have a little bit of a dodgy reputation. There were a few manufacturers of hoverboards that weren't sourcing the best batteries or weren't treating them well, and there were some highly publicized fire issues. So I've always been a little bit suspicious of these batteries. That said, the ones that I've taken apart over the years to source their cells for other projects, they've usually been high quality cells inside, either Samsung or Panasonic 18650 cells. But as with anything that's starting to get up there in age and battery technology, I'm going to keep a pretty close eye on these as we go forward. All right, so I've now got positive soldered to positive, negative soldered to negative. We're going to slide that heat shrink down to make sure that we get a good coverage, because really don't want these batteries shorting against each other in any way. They can put a lot of current out in a short time, and it'll really screw up the battery. All right, there is our adapted cable that should go from our charger to our battery. Now I just got to clean up around here, and we'll move back to the other room. Okay, we're back in the conference room here. We've got our sketchy batteries, our equally sketchy, freshly soldered charging adapter cable, our original hoverboard lithium-ion battery charger, which weighs so little it's hard to believe there's anything in here. Now, because of the general level of sketchiness and unprovenness of this setup, I'm not just willing to plug these batteries in and assume everything's going to be okay. There's a lot of energy density in these batteries, and there's a lot of things that can chemically go wrong, especially with batteries that are a little older. I have always been a huge proponent of charging lithium-ion batteries inside one of these charge-safe bags. Back when lithium-ion batteries were still kind of new, about 10 years ago, these were super common. I haven't seen them as much recently, but for today we're going to use it just because I'm not really sure what's going to happen. So our plan is we are going to plug this into this, into this, plug that into this extension cord. But before we do that, I kind of want to know what we're going to do if something goes wrong. We are in a room, a little conference room that's next to my office. So over the next few hours, I'll be sitting next to this, checking it in on it every few minutes to see what the battery is doing. If something does go dramatically wrong, like we start to get smoke, hissing, or flames, just at a frame here, there's actually an open window. The plan is to rapidly unplug the charger, take the entire mess, and chuck it out the window. Hopefully we don't get there, but it's good to have a plan. So we will start by plugging this into the battery. Then we are going to take the charge lead and plug it into the charge port. Let's see what that does. Got to line up that key there. Just in that moment when I tried to plug it in, it actually cooked one of the pins a little bit. That's not a great sign, but give me a second. Let's see if I can clear that. All right, so that was something of an inauspicious start to this experiment. What happened was when I went to plug the battery into the charger, there was enough current coming back to the charger, I'm guessing to fill a capacitor in there, that it actually cooked one of the little female pins in here and put a little ball of metal on it so that it couldn't be pushed together. That right there makes me a little suspicious of this whole idea, but I'm betting that there's a piece of circuitry that can be put between here and there to prevent that from happening. Obviously, that is not an ideal scenario. I think also it would work a little better. The pins in here are purposely offset, I think, to try to prevent that from happening, but this is going to require a little more research. We are going to press forward, but we're going to do it very cautiously. So now I will slot those two together, screw the little locking ring on just because it's fun, and now we will attempt to put these two together, this end of the the T60 with the other end. And we got another little flash inside there, but the T60 seems to have handled that a little better. And now, put that battery a comfortable distance away, put this battery in the charge bag with the lead out so we can see what's happening there. Close that bag up. Okay. Now, lay our charger out. I mean, the branding on this thing just inspires so much confidence. MXPOW, lithium-ion battery charger. I mean, literally, it feels like there's a sneeze and a prayer inside this box, but let's see what happens. Okay, everyone do your best Doc Brown impression. We're going to plug that in. Okay. We got the little fan whirring. We got a red light. And we don't have anything exploding yet. Oh wait, it just went green. Hold on, let's see. This says red LED indicates charging. Green LED indicates fully charged or disconnect. Well, a couple of possibilities. Either that battery is already fully charged, which is possible because they're recently ridden inside this thing, or something screwy is going on. Well, let's try the other battery real quick. So I'm going to start by disconnecting the charger, disconnecting this battery. Take that battery out of our charge safe pouch. That was battery number 1. Let's try battery number 2. Tuck this one in there. Plug it back in. Still getting that spark. I'm going to have to do some research to see how we can prevent that spark. Now, we're going to attempt this again. Alright, so we have the same behavior again. We've got the red LED here. We've got the fan on in the charger. And we've pretty quickly gone to green. I'm not sure if this is working or not. We're going to have to do a little bit more digging. Hope you guys have enjoyed. Sorry we didn't have any definitive answers for you, but sometimes that's the way this stuff goes. It's just a lot of experimentation. Have a good afternoon.